This is the part where we're going to get the electronics sled set up, and this is what we call the electronics sled, and it, true to its name, it holds all of our electronics and it slots into the back of the machine and it comes out for maintenance and things like that. So it's an easy part to find. It comes from the solid colors. It's got 2 distinctive slits in it and 3 holes. We'll also need our Arduino Uno on this step and our little breadboard. To round things out, I have 3 12mm screws and 8 nuts. So the first thing I want to do is a little bit of conditioning. So these 2 slits are for strain relief, and we're going to thread our wires through those so that if anything accidentally gets pulled, it'll get caught in the strain relief and it won't pass that strain on to our electronics and pull anything out of its connections. So I need a little bit of sandpaper, so I've got some fine grain sandpaper here, and I'm going to cut with my trash scissors a little strip of this. And what I want to do is, because of the laser cutting process, the edges of these can end up being kind of micro serrated, which can scrape the insulation off of our wires. So what I'm going to do is just pass my sandpaper in here and just kind of lightly sand that edge just by plunging the sandpaper, or you can grip it on 2 sides like this, but it doesn't need a lot. I just want to make sure I get the front and the back. And once you start seeing powder like that, you know you've probably moved enough plastic that it'll address the issue that we're concerned about here. So we're really just trying to knock those edges off of the laser cuts, and it doesn't take much. Front and back. Enough. I'm just going to get the dust off of this. Great. And the way strain relief works, and I have one of these long leads that we made earlier in the process, we're going to send these wires into the strain relief like this and then thread them back out for the connections. So this wire will go on to be connected to our electronics, and this wire heads on into the box, and then if this gets tugged on, as you can see, I can tug on this wire and it doesn't pass the force along to the end that's going to be connected to anything. So the next step is to get the Arduino installed, and the correct way to do that is to hold the sled like I have it here with these 2 holes on the left side and up near the top. And I'm going to pass these 12mm screws in from the back and put 2 nuts on each one. For now I'm just going to put 1 on. And 1 goes also into this hole. What we're doing here is making our own standoffs for the Arduino, so we don't have to actually buy standoffs as part of the kit, just to use 3 of them. So I'm going to go to each of these bolts, machine screws, and tighten them down. Just like that. Now I'm going to add a second nut to each of these. And that's going to create a little bit of space between the sled and the Arduino for all of these pins that stick out of the bottom. Okay, And we hold the Arduino like this with this big silver block in the bottom right corner. And you can find the 3 holes in the Arduino that these screws are meant to interface. Now, this one here is very, very close to this edge connector, and we won't be able to get a nut on that one. But as you can see, it's supported from below, so we're okay with that. But these 2 over here, with a little effort and some patience, we'll be able to get a nut onto each of these screws to hold that down. And I'm just going to hand tighten that. We aren't able to turn this screw any longer because we've tightened 2 nuts onto it. So all we're really looking to do here is hold the Arduino down. We don't need a lot of force for that. This one's kind of a pain because it's also close to a connector, but it does give us enough room to put a nut on. And then I'm just going to gently tighten these, my pliers, making sure that I'm not hitting anything on the Arduino board. There. Alright, so now that's attached to our sled. The next thing is to get our breadboard attached. Now some of these little breadboards, these little 170 point breadboards, have letters and numbers molded into them, and those are the convenient kind. What I have here doesn't have those letters or numbers. I have a couple different ones. These I bought a big pack of them. I think I'll use the yellow one. And where this wants to live is here on the board, on the sled. We want to have it near the Arduino in the center here, lined up with these strain relief. Now, if you do have a breadboard that has letters printed across the top or printed across it and numbers down, you'll want to situate your breadboard so that your letters are here at this top edge. As I said, this particular breadboard doesn't have that, so when it comes to wiring, I'll have to do a little more counting, but it's not a huge problem. But I'm going to peel the adhesive off the back of this guy and get him stuck to the board. So again, I'm going to try to center it between these strain relief slots and put it really close to the Arduino. Just like that. Press it in. Now, before we continue with our electronic sled wiring, we need to stop and get the Arduino programmed. And to do that, we'll need a computer. So you can probably see the edge of my laptop computer here. So I'll probably cut back and forth a little bit between the video of the board here and what I'm doing on my computer itself. I have my USB-A cable plugged into this laptop already, so this end of it here will go right into this socket on the Arduino board when it's time. And also, you're not crazy. I have swapped to a different copy of the Electronics Sled. This is one that's in a khaki colored acrylic with a red breadboard, and that's because I'm building 2 crow boxes at one time here. So I'm not doing it to confuse you. This is exactly the same as what we just did with our electronic sled. So now to program the Arduino, we'll need the software to do that. That's called the Arduino IDE, and that's free software that you can download from the Arduino website at arduino.cc. So just go there and download the right version for your operating system. Windows or OS X. In this case, I'm going to be programming this on Windows. You'll also need to download our software for the Crowbox operating system, which we call CrowS. That's available on the crowbox.com website. So you can go and get that. You'll download that. It'll be a zip file. So just unzip that to your computer. Once you have the CrowS software unzipped and you have the Arduino IDE installed, we can get moving. So I'm going to switch to showing you what I'm doing on my computer here. So I'm going to go to my downloads here where I downloaded the CrowS software and look for crowS.ino, which has a little Arduino icon next to it, and just double click that, and that's going to launch the Arduino IDE. Now when you run this for the first time, I'll warn you that it might pop up and tell you that there is a or there are rather, updates available for some of your libraries. And if it says that, just say that you'd like it to update the libraries. And you'll see down here in the output window, the status window, it'll tell you, what it's updating and when it's done. So now, once we have the Arduino IDE opened with our CrowS software loaded in, I'm going to show you here on my little desktop, my actual desktop, not the computer desktop. I'm going to take the USB cable and plug it in to my Arduino, and that will power up. And then I'll go up here in the Arduino IDE to select board, and right here it says Arduino Uno COM3. Don't worry about the COM3, that's just telling you which port it found the board on, but you want to select that. And then there's a little button over here to the left that says upload. It's a little arrow pointing to the right. We're just going to click on that, and it's going to compile our sketch, which is the CrowS software, and then update it, or upload it rather. And then right down here we can see, oh, it went away, but it said done uploading, which means we're done. So coming back to my actual assembly here, it's safe for me to unplug this USB cable here. And with all of that done, now we have the CrowBox operating system, the CrowS, loaded onto our Arduino forever. It's saved forever on there. And we can go back to our wiring. You can ignore this masking tape I have here. It's just there's a very shiny part of the Arduino under that tape, and it was flashing the light back into the camera, so I covered it with tape. The Arduino itself is pretty shiny too, but we're just going to have to deal with that. We'll need our terminal blocks, and when we talked about terminal blocks earlier, we talked about how you can get the kind that either have 3 terminals per block or the kind that have 2 terminals per block. The thing about this is what we need is a row of terminals that give us 9 total terminals. So if I take 3 of these 3 terminal blocks and hook them together, that gives me the 9 connections that I need. In the case of these doubles, I'll need to put 5 together. And of course, I'll have 10 available terminals when I do that. And that just means that 1 is going to hang over the breadboard edge, which isn't all that severe of an issue. So I would say that just get the kind that you can get, or that you like the look of, or whatever your criteria are, because either of these will work just fine. But you do want to have these separate for this step, so I was putting them together to demonstrate, but I'll be probably using these doubles in this step, simply because I think they're the most common type, the easiest to get. We also need a breadboard jumper kit, and this is just a big old box of solid core wire that is stripped and bent at one end, and it makes it easy to make breadboard connections. This is a really big kit. You can get smaller ones. It doesn't matter what size you buy, you'll have plenty of wire for what you're going to be doing here with me. So just get what you can get. We'll need super glue, and this is the only place in the whole kit we're going to use super glue, and that's because the breadboard and the terminal blocks need to be secured in place, but neither of those types of plastic react with the cement that we use. So we need to use a more conventional adhesive. A pair of tweezers is pretty helpful. From the CrowBox website, you're going to want to print out the wiring guide. And this is a pre-release version of the guide, the version that exists at the time of recording this video, but there'll be a much nicer version on the website for you. And it will include a smaller drawing, or version of this drawing, and all we're illustrating here is how the tie points in the breadboard are designated. So you can see that along the long edge we have them numbered 1 to 17, and along the shorter edge there's two sets of 5 rows, A through E and F through J. And you can see how that relates to the actual breadboard. The thing is, sometimes when you buy these little teeny breadboards, you'll get ones that actually have the numbers and the letters molded into the plastic for easy reference. In this case, mine doesn't have those, so I'll actually be counting when it comes to figuring out which holes to put wires into. But that's okay. It's not a serious problem. But when you look at the connection guide here, and it says C3 is connected to C7, that means that we'll come down and find the row for C and then over to 3. We'll stick our wire in there, and then again in row C we'll stick the other end of a wire into 7, and we'll have a connection that looks like this across the breadboard between those 2 points. And then as we do those, there's a little box here you can check off the ones you've done. Double check each one before you check it off, just because it's so much easier to avoid wiring errors now than it is to look into why something isn't working correctly later and find that it's just a wiring error. I thought that we used to, in previous versions of the kit, we used to describe what color wire to use for which connection. That's back when I thought these were standardized colors, and I've found now that I've bought several kits and talked to people who've put other crow boxes together that it's not even close. So we don't don't make recommendations on what color wire to use any longer. You just need to find the right wire in your kit to connect the tie points, which is the name given to these holes in the breadboard. You just need to find the right wire to span the tie points that you're connecting in that step. So that's it for prep for now, and I'm going to get straight on into wiring. So my first connection is C3 to C7, and you don't have to necessarily watch this whole video as I make these connections, because the chart gives you all the information you really need. But if you want to follow along, that's fine, and I will make the video just in case you do. So C3, so I go A, B, C, and then 1, 2, 3. So that's 3. And then 4, 5, 6, 7. So this jumper is where I need it. So I'll just push both wires in and then push the whole thing down. So I'll verify that one is in the right place. A, B, C, 1, 2, 3, 4, 5, 6, 7. Okay, that one checks out, so I will check it off. Next is D7 to D11, according to the sheet. So I know that we were just into C7, so D7 is just below that. And then the other end is D11, so this is 7, 8, 9, 10, 11, which is correct, so I can push this wire in. D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay, checks out. C11 to C15. Oh, even though the insulation colors of these wires aren't standard, the lengths of the wire are. Breadboard jumpers are made specifically for making the kind of connections we're making. So for just about everything we're doing, there'll be a perfect length of wire, or jumper wire, to make the connection that you need. The only exception is some of the connections between the breadboard and the Arduino. That's a different problem in terms of distance. C11, C15. So C, 11, 12, 13, 14, 15. All right, that one's good. E1 to F1. So this is A, B, C, D, E, 1, and that's F1, so we're doing a vertical one this time. That's E1 to F1. E3 to F3 is the same connection, just a couple doors down. E15 to F15. So I know there's 17 holes across. So if this is 17, 16, 15, E and F right across the gutter there. So that one's good. J1 to D13. It's kind of a funny one. J1 is this bottom left-hand corner. And then A, B, C, D. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Goes to right there. So I'm going to grab one of these gray wires, I think, for that one. And I'll go ahead and put it into J1 down here in the corner. So that end's taken care of. And then get to D13. So A, B, C, D. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There. Okay, so that's all the connections that are on the breadboard alone. Everything else runs from the breadboard to the Arduino. And that brings me to a part that I forgot to mention, which is this little 6mm push button that we need to put down in this bottom right-hand corner here. Now these aren't necessarily designed to go into a breadboard, which is okay, but that means that these pins, I like to straighten them, and I do that just by squashing them with pliers like this, needle nose pliers. The other thing about these switches is that you can see the two legs actually come out of this side of the button and this side of the button. And you look from this side, nothing actually comes out of that side. This is how you want to put it into the breadboard. With the side, one of the sides with the pins actually coming out, facing you. So after I've straightened those pins with my pliers, I'm going to fit it into this bottom right hand corner just like this. Push it in gently. I don't want to force anything here. Make sure it goes. And it does. So I'm happy with that. And what I want to do, because that part doesn't really have anything to hold it in place very well, is I'm going to put a little bit of super glue on the back of that. There. And then remember, keep one of the sides with the legs actually coming out of the switch body near you or toward you. And And I'll just push that right in, and the super glue will bond that there to the breadboard, and that way this switch can't get knocked out later. And I like to put the button in at this point because we're going to be crossing the breadboard to the Arduino on the next couple connections, and it's nice to know that that button is already in place because most of the pins we're going to need to get to are right along here. So we're going to want to go either under this button or around it. So, connections from breadboard to Arduino. G1 to the Arduino 5-volt pin. So if you have a genuino Arduino, the pin designations will be silk screened on the outside of this connector here, but they're also printed on the board itself right next to them. So you can use whichever of those methods are available to you to find the right pin. But the 5-volt pin that I'm after is right here. So let's see, we're going to go from G1. So A, B, C, D, E, F, G. G1 to 5. So it looks like probably want this orange wire. So I'm going to push this end into G1. And route it around so that it goes into 5V. And that's going to bring 5-volt power into the Arduino. And that checks out. G3 to Arduino ground. That's about the same distance as the connection we just made. So if this was G1 here, that means G3 is right here. And I'm going to use the same routing because I'm going right next door to the 5-volt connection we made just a moment ago. Into ground here. There's two grounds side by side, doesn't matter which one you use, but I like the one right next to the 5-volt. So F17 to Arduino pin 4 is my next connection, and I know that to be the 17th row is the far right hand row, and F is the far right hand column, and F is the first row after the gutter here. So we just need a little short guy for this one to get to pin 4, which lives right here. This yellow one will do it. I'll put it in pin 4 first on the Arduino and see if I can get it where it's going here. I think so. There, great. So it's A, B, C, D, E, F. Yep, 17 to pin 4. E5 to pin 3. So that's a bit of a longer one. I wonder if this gray one will do it. E5. 1, 2, 3, 4, 5. To pin 3, which is right next to pin 4. go. E9 to pin 2. So the E row is filling up on us pretty fast, and I covered one of those holes, so I'm going to just bring that wire down. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's correct. To pin 2. A little bit longer of a wire than I would like, but okay, D17 to pin 9 is our last wire. So that's going to be on the far right edge here. And D is A, B, C, D. So right here, we're going to route that to pin 9, which is over here. Which means I can probably use, not that. Yep, it's going to be a gray wire. And that's going into pin 9, which is right here. So that's A, B, C, yep, D17 to pin 9. Brilliant. So that's all our wires in place. But we do need to put our terminal blocks in. As I mentioned before, when we use these little doubles, these double terminal blocks, we have to use 5, which gives us one extra terminal. And that's going to hang over the right side of the breadboard here, and it's not going to cause anybody any trouble. The important thing to note, though, is which way to orient these terminal blocks. So the correct way is with the actual terminals facing these two little slits here that we have, because as you might recall, those slots are that's the strain relief for the wire that we're going to be connecting to these terminals. So we want to make sure that the terminal receptacles are actually facing where the wire is going to come in. The other thing to keep in mind is that these terminals hog up a bunch of space, and as you can see, we're really close to this wire here, and that's okay because there's enough room. But if your wire was somehow bent or just leaning the wrong way a little bit, you might not have all the room you want to put your terminals in, so just double check that the fit is going to be okay. And we're going to start using super glue here on these guys, because normally these get soldered to a circuit board, and that's how they get installed into things, and we're not doing that. So I want to make sure that they stay in place. So I like to glue them. The other thing I like to do is glue the terminals to one another. And that's a little bit trickier because they fit each other very tightly. And so there isn't a lot of room for glue. So I try to use very little so that it doesn't squish out all over the place. I'm going to cap that super glue for a second while we talk. So if you look at these terminals, you'll see there's a very tiny rail here on the right side of this block and a very tiny slot on the left side of this one, and you'll need to line those up together like that. You can see that they're hanging on each other even though this one isn't pushed in yet, and then you slide this down into place. So what I like to do is smear a tiny amount of super glue onto this one, about halfway down, and then put my super glue on the bottom of this one, then slide them together. And then push this guy down into the breadboard, just like that. And I would warn you to use a little less super glue than you've seen me use these couple of times. I squeezed my tube a little bit, and it's putting out more glue than I like. So I'm trying to get that under control, but with a little metal tube, it just keeps flowing. Okay, 2 more. Okay, now we've reached the last one, which is the funny one when you're using these double terminal blocks, because that's where our extra one will end up hanging over the edge a little bit. But it doesn't really change how we put it in. Still want to line up its slot with the little rail on the one next to it, and then we'll push this one into the last hole, and you can see how I think you can see, if I can find the right combination of camera and light, you can see how that last pin is just sticking over nothingness there, and that's okay. We're not actually going to connect anything to it. It looks maybe just a little bit funny, but it doesn't hurt anything. So that's a perfectly serviceable electronic sled, which we're going to put aside now for a little bit. We want to give that super glue a little time to dry before we start turning these screws and connecting wires to everything.